Hello everybody, in this video we're going to be covering triangle congruence proof, SSS, the reflection transformation, and the concept of rigid transformation. So let's get started. So in this video we're going to be doing triangle congruence proof, SSS. So SSS stands for side, 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 and that means we have two triangles with all three sides being equal, and we need to prove that they are congruent. So here we have our SSS proof, and we have two triangles, triangle ABC and triangle DEF, and what's given to us is that side AB is equal to side DE, so these two sides are the same. Side BC is equal to side EF, and these two sides, which I've put on top of each other, these are sides AC and DF. In this diagram, I've put them on top of each other, and they are also equal. So what I'm going to do is I'm going to draw an arc with C. Let C as the midpoint, and CB, or FE, being the radius. So what we'll see is that this arc is going to intersect with points B and E. And if we did the same thing from point A, using AB as the radius, or DE, and it intersects with points B and E. And something you'll notice is that these two arcs also only intersect at those 2 points, and no other point. So if we were to consider an arbitrary point X, this X would be this same distance from C, the same BC distance from C, but it would not be the same distance from A as E and B are. If I took a point Y, it would be the same distance from A as E and B are, but it would not be the same distance from C. So if we used now a rigid transformation reflection on triangle DEF on the axis AC, so if we did reflection on DEF across this axis, so points D and point F are on this axis, so they wouldn't move. What point would move would be point E. So the question is, where would point E end up? And we know that reflection is a rigid transformation, and if the transformations are rigid, that means that the dimensions have to stay the same. So the only way across these two arcs where these dimensions here would maintain the same would be if E goes directly onto B. So if E prime, if E prime maps to B, that's the only way that the dimensions would stay the same, because we know that DE is equal to AE, and BC is equal to EF. So that would be E prime, this would be D prime, and this would be F prime. And what we've done here is we've essentially mapped DEF directly on top of triangle ABC. So if we can map the triangles on top of each other, that means all the details about the triangles must be the same, which means all of these angles here have to be the same because they map directly on top of each other. So all of these I can mark as proven. So because all of these conditions were met, that means triangles ABC is congruent to triangle DEF. Thanks for watching. If you liked this video, please drop a like and subscribe, and I'll see you in the next one.